Hey there, this is Mr. Wilford, and I was going to go through Chapter 4, Section 7 here a little bit. Introduction to Coordinate Proofs. And if you've done proofs before, you might like these because, let me show you this. Coordinate proof is a style of proof that uses coordinate geometry and algebra. And if you enjoy doing some algebra, you'll enjoy coordinate proofs. And even if you don't, this seems to be a little bit better in terms of it's a little bit more concrete when you're trying to prove things. Um, there are some strategies here for talking about coordinate proofs. There are some strategies of how you line up some of the geometric figures that you're talking about. The first strategy is to use the origin as a vertex, keeping the geometric figure in the first quadrant. And basically what we're looking at is this example here where we have a rectangle, and you'll notice that one of the vertex points of the rectangle is positioned here at the origin, and this is the first quadrant where the x-axis and the y-axis are both positive. That makes things a little bit easier. Another strategy is to center the figure at the origin, and an example of that isn't detailed here, but if you talk about a circle, for example, a circle you want to have centered at the origin. Center a side of the figure at the origin, and that would be like this example here where we line up the rectangle and we have it centered at the origin. And then another strategy is to use one or both axes as sides of the figure. And that would be this example again where we have the sides of the rectangle part of the x and the y axis. So just setting your geometric figure up here with what makes sense and to make things as easy as possible for you. If we take a look at an example on the next page here, one of the things with doing coordinate proofs is you want to make sure, because of the algebra involved, that you're familiar with some formulas. A couple of formulas that are common would be the distance formula and the midpoint formula. And looking at this example here, what we're trying to do is, if you notice, we have a big triangle here, ABC, and then we're going to look at another triangle right here, triangle DBC. And the problem here is that we're trying to prove that this area right here of the little triangle is half of the big triangle ABC. And basically the way that this is done is you first find the area of the big triangle ABC, and the area formula of a triangle is 1/2 base times height. And if we locate this big triangle here with one of the vertex points at the origin, it's real easy to count the units here. So the base would be 4, the height would be 6, and if you do the math, we get 12 square units. Using the midpoint formula, we find that point D is located at 2, 3. And then again, using the area of a triangle formula, 1/2 base times height, and looking at this little triangle, we have a base of 4, a height of 3, and doing the math there, we get 6 square units, which is indeed half of 12. Alright, the other thing really quick to mention here is that you don't always do proofs with actual numbers. Sometimes you do these proofs with generic variables in kind of a generic way, and you'll see that here with a couple of examples where you have a triangle, one vertex is located at the origin, and then you don't know the exact distance of these sides, so you label them with variables b and a. Same thing right here as well. And that's what kind of this example shows a little bit here with some of the variables that are involved. If you want to take a look through that example, it's a pretty good example. Alright, again, if you have any questions, please let me know. Thanks.